Hey everybody, this is Larry, this is me going over Q2 of the bi-weekly contest 82, the latest time to catch a bus. You know what they say, the best time to catch the bus is the last bus, and the next best time is now? Huh. Okay, that's probably not the saying. Anyway, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this farm. So the way that I did it, I think there are clever ways to do it. I think you only have to check certain things, but I think that it gets too tricky for me to think about. And I spent actually a long time on this. I've spent about 13 minutes, just because I was just so worried about the edge cases, right? But I think I have a visualization I think I have a good observation and stuff like this to make this easier. And the way I did it was with binary search. I'm just going to do the binary search part very quickly. Yeah, let me write this. So first of all, you should note that you need to sort the buses and the passengers. I think this part makes sense. Hopefully I don't have to explain it, but it's just that so that we line up the buses and the passenger in increasing order. I mean, I feel, this is pretty straightforward, right? And then next is binary search. And the question is, okay, the good here is, can we leave at mid-time, right? And I'm not going to go over binary search too deeply in this particular problem explanation. I have a lot of binary search videos, so definitely check out one of those and practice those. But because I think this one is harder to write the functions, I'm going to focus on it. But the idea is that if you think about this function, if you write it one at a time, you can be like, yes, I can leave at this time. I mean, technically, there's some parts of it is false because another passenger is arriving at the same time. But for a given part, you have something like this, right? That means that you can arrive here, and then here it's going to be too late, right? So then now we have some ideas. So the idea is that, okay, if this is true, what happens? Well, if this is true, so this is one of these, that means that we can try to go for later while maintaining the current index, right? So then now the left index is here, and then the right index is all the way here. So then now we want to get rid of everything to the left, because that means that we don't have to consider it because we have a good answer. So that means that we move the left to the mid so that we eliminate everything to the left. And then the other case is if good of mid is false, right? Let's say it's here. What happens? Well, that means that mid cannot be true because we cannot leave at mid time, right? If we cannot leave at mid time, then everything higher than mid is also going to be, well, we cannot leave then either because they're also too late. So then we try to eliminate mid and everything to the right of mid. So then we eliminate those by moving right to mid -1, and then we add one here for rounding error type things. And for this particular problem, because we cannot leave when a passenger leaves, so here I just go, okay, if we try to leave at the same time, then I just move the time by one more. That's just like almost like a dedupe thing, right? And then now the question is, can we leave at now target time? I think this one was a hard function to write. I think that's why a lot of people took a lot of time, even really smart people, right? Like really fast people, like like these people have like 3,000 rating in Leetcode or something, right? And they still, okay, well, some of them are fast, but for the most part, maybe they skip forward a little bit after looking, right? So yeah. And then the idea for me is two things. One is that, let's see. That means one is that you don't care about the passengers that leave after you. So that's my general idea, is that we don't care, right? So then the question is, then now we just simulate the buses and how they leave, right? And here we go, okay, for the I bus, and keeping in mind that this is sorted, for the I bus, if we still have passenger in the passenger list, that's what this J less than P is meant for. If we have and they can take out this bus, then they will take this bus, right? Because if there's still capacity, then we take this bus using this passenger. And then of course, as we said, every passenger that leaves after the current time, we just ignore because we don't care, right? Like it's over. And then here, if the current capacity is over, then we just move on to the next bus. Of course, if there's more bus that's left, then we just sat. Otherwise, yeah, otherwise we do have room left, and that means that order invariant has been held. That means that the target time, yeah, if the target time or the current time that we arrive, if this is before the bus gets there, we return true, because that means that we got on this bus, yay, right? That's basically the idea. If all the buses are gone, then we return false. So that's basically the binary function. And yeah, it's kind of really hard to, I mean, I know that this looks really, short and it's really tight, and maybe the way that I explain it makes it seem easier. But to be honest, like I said, this might be one of the hardest Q2 that I have done in a while. So yeah. So definitely, if you don't get it, don't feel bad. And also, like I said, like I spent about 13 minutes on this because I was worried about a lot of edge cases. So it's definitely very, 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 very easy to make these edge case errors. I think the one that made me figure out how to implement this cleaner is to realize that we don't care about the passenger afterwards, because in that case, then I can early terminate and just get on the bus, right? So that's basically the idea. Is this idea of almost simulation, but also like being really careful about the target time. So what's the complexity here, right? So here, this is going to be O of n plus m, or I call it. How did this get here? But yeah, I call it B and P for bus and passengers. I think it's cleaner. This is over B plus P, and here, this is going to be, let's say T is equal to the range of target. Then this is going to be O of log T, which in this case is going to be 30 iterations or so, times cost of each iteration, right? And so that's going to be log T times NQ. Or maybe just, why does it say NQ? What does NQ mean? I mean, B times P, I think I'm thinking of another problem already. So that's the complexity. In terms of space, we don't really use any space. Oh, okay, I lied. I actually forgot about the sorting. So actually, so this is the cost of the binary search. For the binary search, but of course you have the sorting. So the total complexity, it's going to be O of B log B for sorting, plus P log P for sorting, plus B times P times log of T time, right? And space, whenever I sort, I always assume that we make a duplicate. We don't actually, but because it's kind of weird to, mutate your input. But for competitive, I'm going to do it this way. And the idea is that this is going to be over, we sort it, so we use the space, so it's B plus P space. Cool. That's pretty much all I have for this one. Let me know what you think. Let me know how you did. And you could watch me solve it live in the contest more deliberately now. Departure. That's very wordy. Okay. First bus. I do this well? Okay, maybe this is a little bit easier to see. First pass, second pass, and then the third pass. Okay, when they say third pass, they don't mean pass 3. That's why I got confused. Okay. I mean, a couple ways to do it, but just thinking really quickly. No, let me know. What's the better logic? Why is only one done? This should be time limited. That's why we're a little bit. It's so hard to get right. do you even do this? Maybe I should have skipped this one. This was always, knew that was going to be hard. I don't know how to do this one quite easily, implementation wise. Okay, so you can always stop at passenger 1 or time 1 rather. Okay. That's unfortunate. Give it when we get to 20. Nice. That's like, is that right? Oh yeah, that is right. Okay. A lot of possible silly mistakes. Also, maybe time limit exceeded. Okay. Whew, that was a hard one. Yeah, give me some support. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problems. I'll see you later. Stay good, stay healthy, and good mental health. Take care. Bye bye.